Alright, guys, welcome back to the third video of our series. Uh, right here we have uh, our third or four points that we're gonna discuss in this video. Determine whether or not a sequence is arithmetic. Find the general term for an arithmetic sequence. Find the specified terms of an arithmetic sequence. Find the sums of the first n term of an arithmetic sequence. Now, there are many types of sequences established in high levels of mathematics. In the next two sections, that it will be the third video and the fourth video, we will discuss two types of sequences, arithmetic sequences and geometric sequences. But in this video, we will discuss only arithmetic sequences. Now, in short words, we are going to find sums of only finite number of terms. But in the next video, in episode 4, we will discuss geometric sequences. And still, we're going to explore finite terms, but we're going to define what it is to add an infinite number of terms. We're going to define that in the next video. Um, So arithmetic sequences are closely related to linear functions, as explained in the previous video. Let's take the formula. Right here I have the formula ak plus 1 minus a parenthesis k minus d, where d is the common differential. This sequence is called an arithmetic sequence or an arithmetic progression. So the sequence is arithmetic by finding d. Okay, so now we have this. Let's put it here. Okay, we have AK is equals to 2k minus 3, and A is equals to k plus 1, and this is the formula. The formula is A sub k plus 1 minus A sub k equals D. Now I want you to see something that we are going to replace A sub k and A sub k plus 1. That's the only thing that we're going to do. So if AK is equal to 2k minus 3, we're going to put this in parentheses. And outside of the parentheses, we're going to write 2 times k plus 1 minus 3. This will be equals to 2k plus 2 minus 3. This is equals to 2k plus 1. 2k minus 1. Now, if you don't understand what I'm saying right now, we are only substituting the n because the n in this case is k plus 1, but I put an n here, and the minus 3 is minus ak. But of course, this section is very similar to a chapter in mathematics where you have a variable, and you're just trying to get the value of the variable and then add it on the formula. This, I don't know if someone learned this in algebra too. Okay, so we're just replacing the n by k plus 1. So it will be 2k plus 1 minus 3. Now, so I wrote it here 2k plus 2 minus 3, because that minus 3 is outside, but we still have to do something with it. So it will be 2k minus 1, because 2 minus 3, if the number it's in front of it of the of a normal operation like plus and adding, but in this plus and adding, plus or subtracting. If the number right here 2 minus 3, if this number is smaller and you're subtracting a bigger number, the number will be negative. But if this number it's bigger than the other number, if the 2, if we substitute the 2 by 4, in subtract 4 minus 3 will be positive. If you can recognize this very quickly, you don't have to battle. And you may not, you sometimes you get confused because if this minus 2, if this is not a positive but a negative number, like a minus 2, minus 3 will be minus 5. But if this minus 2, you add a 3, it will be a positive one. So, but it's about knowing the rules. I'm wasting my time here. I'm wasting your time here. But if somebody find this interesting or easy, there you have it. If the first number here is smaller, then it will be negative. But if the first number in front of it it's positive, it's bigger than the one that you are subtracting to, it will be positive. Okay, let's go. Let's keep going. So we have 2k minus 1. We have 2k minus 1 minus 2k minus 3. Now, what are we doing, right? Because, like I said before, the result, the 2k minus 1, is like it's, I wrote it here. We have found the k plus 1. So we found not the ak, but the ak plus 1, this part of the formula. Because we have this, because ak is equal to 2k minus 3. But that 2k minus 3, we substituted the k by k plus 1. But now we have found this, this, the first formula. I will bring another video explaining this with touching the algebra section that is very similar to this. It can get very difficult. I remember doing a division, and it's an exponential at the same time. It gets crazy, but it's beautiful. Okay. So now that we have found k plus 1, now the only thing we do here is, so we have 2k minus 1 minus 2k minus 3. Now that, right, we have found that ak is 2k minus 3, so we put that in parentheses because now we want to find the d. And we do 2k minus 1 because 8k plus 1, we just found it, so we just replacing this in the other one. And now we get the d, the or differentiator. At the end, we saw that 2 was the final answer. 2 was or d or differentiable, meaning that the formula did work. But if we put everything in linear function, we will work the same. The point here is to find if the sequence is in arithmetic sequences, if it's consistent, as we know the d was different. The formula for the n terms of an arithmetic sequence, if n is an arithmetic sequence, then the number of terms has the form of an equals a1 plus n minus 1d. Now I want to show you what that is. Okay. Now, because in the formula we subtract the terms, I'll do the same here, subtracting the first term and the second. And it'll do the same with the third and fourth term. So let's do another example, okay? We wanna see if this sequence n square is uh, let me see, is consistent or not consistent. It's not this. So we have n squared. This is another thing that you may, I think, if the teacher show you this, but it should show you this in algebra 2 in high school. But if you may remember this in high school somewhere, I will explain it right away. So we have the n square, and we wanna see if the sequence goes straight or it differs. Like it can go down, a little up, go down. That we wanna see if it's consistent. Straight line, or whatever. Okay. N square. So we have 1 square, 2 square, 3 square, 4 square. So right, we have our answer 1, 4, 9, 16. Now we want to find our differentiator. So this is a way of saying, okay, so you don't know, you can remember the formula, the a sub k minus a sub k plus 1 is equal to the differentiator. If you don't know, cannot know the formula, you may want to use this one. So you want to take a first term and subtract it to the second term. And then you get an answer, right? So we take the 9 and we subtract it to the fourth term. So imagine we have our tables. So we put the tables, we subtract we switch the n by the first term, the second term, the third term, the fourth term, and we start subtracting the first term to the second term if we had the same results. If we don't have the same results, then this is not consistent. The formula for the n term for trigonometry frequency, where d is the between the comma. Okay, so as we can see here, we have 9 minus 4 is equals to 5 minus d. But if we do the other with another terms, because in we want to see if it's a straight line, or if it gets the pattern. 4 minus 1, it gives us 3 minus d. So it kind of like, you know it's not consistent. So it probably, if we graph this, we go up, we go down, we go a little bit more up. So it's not really consistent, the same. We're not having the same results, so we cannot consider this one in our net sequence. Okay, but is there any easier way to find if we can see if it's an arithmetic sequence or not? Yes, there is. And the formula for the n terms, so we can pick any terms of an arithmetic sequence with this formula. A1b is equals to A1 minus n minus 1 times d. So let's do an example here. So let's look at this. Let's find the specific term of an arithmetic sequence is given the a sub 1 is equals to 5 and the differentiator is 3. So let's find the a sub 16 that's equals to 15. Well, that's the answer, bro. I want to show you how this thing can be done. Let's go back here. So we have a sub 1. This is really fun. Okay, we want to find the answer of the 60th term of an arithmetic sequence. But of course, it can be a little hard if the number is quite large. Adding and trying to find the other number and the other number, it gets too much. So we're gonna use this formula that's specific to solve any number that you may wanna know in an arithmetic sequence. You use this formula. So we wanna find the the a6 sub 16. The number is equals to 16, so find the formula for the a sub n. Now the a sub n means the answers, the previous answers. That's what a sub n means. So we have a sub 1. As I said before in the previous video, in video number 2, this this formula of a sub 1, a sub 2 comes from algorithms from the matrix. So remember that if we have a sub 11, we're really saying this is the 11th term of this arithmetic sequence. So if this is a sub 1, this is the first term that we're gonna use. If we wanna add this first term and we wanna subtract the n, now the n means the last number that we are gonna use, that we wanna find. If we want to find the a sub 16, then we're going to replace the n in this formula. So it will be 16 minus 1. And we want to find d. Remember, the d is the differentiator. Okay, so we have 5 plus 16 minus 1 times 3. It's really easy with this formula to actually find whatever number you may want to use or want to know. This is a really good formula. So 5 times 15 times 3, it's equals to 15. So the a sub 16 is equals to 15. Let's use one of the terms. Okay, so let's do another one. A sub 20. So a sub 1 plus minus negative 1 times d. That's the formula. In this case, the first term of this arithmetic sequence, it's negative 2. We don't know in which base of terms we are keep adding. So later on, I will explain you how to connect these two things. But it's very important to know how to do this separately. It will be more easy if you learn this, and then if when we connect it, it will be a lot more simple. So we have the a sub 1 is the first term, negative 2, plus we subtract the n by the term that we want to get, that we want to find. It will be 20. 20 minus 1 will be 19. Now the d. This is another important thing. So this it's really important because it really connects to the previous thing that we just spoke. If we know the differentiator and we know the first term and we know what term do we want to use, then we can find any term in the sequence. without really, adding one and one and one and one, adding the same term and, doing the whole process, which can be a little tired, can be a little frustrated sometimes. And and this is the best way to do it. But we first need to find the differentiator. And to find the differentiator, we're gonna be using the other one that I just previously explained it to you, okay? So 19 times 10, it will be 190 minus 2, 182. I want to go fast with this because the video will be too long and I don't want that. So the 4 page. So if we have two, like we saw in the previous video, in the last, in the second video, which I present two sigma notation that we're adding, we're doing the same thing here, but in another way, in another way of writing it. We got negative 48 equals to, we want to find the negative 48 term of this arithmetic sequence. And we also want to find the negative 6 term of this arithmetic sequence. Okay? Remember, based on the properties, we can do this if we have the first term. Use it. If we have a sub 1 and a sub 1, we can completely use that's the first uh, property of sigma notation, but we're applying it on this way. So if we have negative 48, we can do simply the same way as algebra, So we have negative 48, negative 6. We're adding it. So if it's negative, negative, it will be negative, negative 40, 54. If we have a so what we're doing here really, it's right. We want to subtract, we want to we want to add it, but in a way subtracting it. So we're going to uh, subtract the negative 6, the minus 8 1, and the 2d. So based of this, we get all of these numbers negated, and then we adding it. We have 54. The first term it cancels, so we only get the d, the differentiators. We got 18. We subtract it. We got negative 3 is equals to is our differentiator. One term we have is that it's equal to 6. Another is a sub 21. It's equals to negative 48. So what are we saying here is, okay, let's pick any term in our arithmetic sequence. We pick 6 and we pick 21. Well, we pick 3 and we pick 21, but we want to find what's 8 1, right? And d. But we already find what's d, so d is equals to 3. Now the first term of this two sigma notation that we're adding, the only thing that we're gonna do is just substitute our differentiator, and we can use any of those sigma notations of these two formulas. So we have 6. We substitute the d minus 3. We subtract it, and it will be 812. And then we had our first term. Let's do this example. So we know that the 10th term is negative 12, the d is negative 3, or differentiator, and we want to find the first term, and a sub n is equal to 72. Now I will explain you what that means. So we use or we're gonna use our formula, the a sub n, which in this case, because we don't know what a sub 1 is at first, we need to uh, first solve the a sub 10, because we need to have at least one term and have another term, and see and try to see the differentiator, right? If to find the a sub 1. So that's what we're gonna do right now. W- we're gonna say that we're gonna use the 10th term. So okay, so we substitute the n by the 10. We subtract it by 1, it will be 9. We know that d is minus 3, so we just multiply. And the a sub n, we already know what that term is. What is the result of the 10th term? It will be negative 2. But we don't know what a sub 1 is, because we have to know the first term of the sequence. So it will be 9 minus 3, negative 27. We move it on to the negative 12, and we'll have 15. 15 is the first term of the arithmetic sequence. So it's going backwards, as you'll see, because the a sub 10 term, it says that we're going negative 12. Okay. So now we substitute the a sub n, which the a sub n is in the formula of a sub n plus parenthesis n, a sub n minus 1. So it's kind of like playing the algebra thing. So now that we know that that we don't know. So I'll tell you right now, the negative 72, it's the term, right? It's the answer, but we don't know what the term is. So we want to find what is the term of that sequence to find. That's why we don't put n, because we don't know what the n term of that sequence that's equal to negative 72 is. We In this case we know that the a sub 10, it's negative 12, but in this case we don't know. So 15 plus n minus 1, minus 3 times minus 3. So we just multiply. Okay. If you multiply two negatives, it will be positive. But if you multiply a negative by positive, it will be negative. 15 plus 3, we subtract this. We pass it on here. It will be 75. We subtract the 15. It will be negative 19, because we're adding negatives and negatives. So the negative goes up, 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 up as a depth. And we ended up having negative 3n. So we just subtract the negative 3n to find the n term. In the n term is a positive, right? Because it has to be a positive. It could be a negative, but in this case, it's a positive. So it's the third term of the sequence is this one. Now, Frederick Gauss, it's an important person in mathematics, which later on when he grew up, he developed a lot of the formulas that we are discussing right now, or you will discuss later on in your mathematics studies. But when he was young, they asked him to add all the numbers 1, the first term of 1 to 100. Of course, if you look at it, it will be really hard, because you only have a chart, because at that time, at the 1700s, you use your chart, you use a chalk, and you write everything. Well, the richest kids use paper, but that's a, I'm not going too deep in that. But the story was that he used this formula. He saw that adding the first term and the last term, as we were doing it, right? Right here, well, in this case we are subtracting, but he he was adding it, as we're gonna look right now. So he was adding the first term and the last term, and then he had the second term and the 99th term, and he saw that he had the same, because if we add 101, it will be 101. If we add 99 and 2, 101. And you can keep going and going, and you always will have 101. So that's our differentiator. That's how we know that the sequence is arithmetic. If we for some reason don't end up having 101 or 102, then we know that that's not an arithmetic sequence. But he knew that. So okay, so 101, then he just multiplied to how many times he got that number, and he got the result really quickly. And but later on, he developed some mathematical mathematical equations, or you know he helped a lot of people. He helped the mathematics to grow, and that's wonderful. But we're going to start it right now. In this 6 page, we just have 3 pages more, and 5 pages more, and we're done. So let's go back a little bit in the last previous video that I just explained to you, and we're gonna sit this, and about the story that I just told you. We're gonna keep using this formula to find the last result, to find the sum of everything, without really doing what we're doing last video. So in this term, like the summation of the first term through the sixth term, remember that the number in front of it is the limit, in terms of 4k minus 1. This is so we just substituting the k by 1, by 2, by 3, by 4, by 5, by 6. And as I did it here, 4 times 1, 4 minus 1, 3. The second term, 4 times 2, 8 minus 1, 7. So I'll just keep doing that, like we did in the previous video. And at the end we just added everything and have 78. But what if we do the same thing as Gus did, right? Use the first term and use the last term and add it. We have 26. Keep doing that. Keep doing. We As we see, we have the old 26, and then we just counted 1, 2, 3, 4, 5, 6, 6 times 26, and then divided by 2. It will be 78. Okay. Now I'm gonna explain you using the same procedures with general terms in the subscription notation. We can develop the formula for the sum of any finite arithmetic sequences. Suppose that the n terms are a sub 1, comma a sub 2. Now to get a sub 2, we need to find what the differentiator. So a sub 1 plus the differentiator. Now if we want to find the a sub 3, will be a sub 1 plus 2 times the differentiator. So if we want to find the last term of an arithmetic sequence, we will use a and minus 1, as we have previously discussed this. So it will be equal to a sub n minus d in terms of the a n term. And the a n term is the term that we don't know. So this is a formula, a n minus d. A special case of an arithmetic sequence is the n, and the corresponding sum of the first n term. In this case, n, the number of terms, a sub 1, and a n is equals to n, so a sub 1 is equals to 1, the partials of an arithmetic sequence. Thus, writing the terms in both ascending orders and descending orders, and algebraically we have s. So I'm just going to explain you how can we integrate what we just have previously discussed in this sigma notation to find a way of saying of finding the last digit, you know, to find the last, so we don't have to do all the summation. As you can see, I wrote it here, but I'm just gonna explain it to you. I'm gonna try explaining it to you. A sub 1 plus a sub 1 plus d, right? We have, we know that if we keep adding a sub 1 plus the second term, that we know that a sub 1 plus the differentiator, a sub 1 plus 2 times the differentiator, at the end of the day, we're going to have a n minus d plus the n term. Okay, so saying, okay, whatever term is the last term, this is the formula. But we cannot stop there, because now we have to do the same thing over again, but with the minus d to find the 8-1. Okay, you will say, what are you talking about, man? What are you talking about, man? We're doing the same thing over, right? Because as imagine it as, okay, whatever is the last term of this, we're going to do it all over again, but we're going to switch it. So we can have 2s as Gauss this. All of these numbers doesn't mean nothing. What's really important here is the concept that I'm trying to explain. As I did, as I did here with real numbers, but I'm doing it here with, wait, come on, here. I'm doing it here with notation. I'm doing it with notation description. So if we add an plus an minus d in this equation, that it's an plus an plus d, you see that the d cancels right here. The d cancels, right? And if we add the first term, that it's 8-1 plus an, we have an plus an in parentheses. And all right, that's our differentiator. Okay, let's do the other one. An plus d, an minus d. Because remember, minus d is our last term in the sequence. But if we wanna use the second term of the first term, we had to have our differentiator. But in this case, because we're adding the two things, the first and the last, the first and the last, the first and the last. So we are having this differentiator, which is 1 minus a sub n. As you can see, we have our differentiator, and this is a consistent arithmetic sequence. So let's put it in context. Let's write it down. A1 plus an appears n times, right? But what's n? N, it's divided by 2 times the summation. So we have this part. And then from here we just say that the AK, it's equals to this beautiful thing. And now we don't have to worry about what's the last term because we just created a formula to find whatever term. Nice, huh? Knowing that the first term has to be always one, right? Because if it's not one, if it's zero, then how is this going to continue up? I mean, it could be there are some things where there you can start with zero, but normally will be equals to one. Okay, the last limit, the limit is it will be wrote as an n, but we also wrote it here as an n. And you know that AK, it's equals to this. Beautiful. I hope you're understanding some of the things. I'm doing it with all of my heart, and I want you guys to learn something, even though if you're in high school or college or you're not understanding something. I'm hoping I can help you something. So let's do two examples, 2 pages more. We have this. We have the first term, the summation of the first term through the 50th term in terms of 3 times k. So we are substituting k, 3, 6, 9, 158. That's the old way of doing it. But if we could we have 158. Now, if we do the other way, the 8k plus 1 minus 8 sub 8k, we know that 3k has to be added plus 3. Now you may say, why? Because 8k is 3k and 8k plus 1, so we have to do this again. So we replace the k, in this case, we replace the k and we multiply it by k plus 1. And we got 3k plus 3. Now this 3k plus 3 is a k plus 1, k plus k 3k 3k plus 3 minus 3k. So we know our differentiator. So 3k is an arithmetic sequence. K sub 1 to the 50th term is equals to 3k. And this is equals to 50 divided by 2 times 3 plus 150. So we're just replacing right now because we know that the last term is 50 and we know that our differentiator is 3. So we put our differentiator here and we put the last term, which is 150. 3 times 50, 150. We add it, we divide this, and we have our final result. Awesome. If you did not enjoy what we just discussed today, you can always go back to the properties that we have previously discussed in the last video, which was in properties 2 and 3 and 4. We know that the last limit is 70 and we use it in terms of negative 2k plus 5. So we just, because we have the same limit, then we just break it up. And we have 70, the summation of 70 to the first term in terms of 2k plus the other one. And then we do this wonderful thing. we just multiply this negative 2 in front of the sigma notation, and we start working from there, 70 divided by 2 times negative 2, it's equals to 1 plus 7 times 5. This is the other one. 1 plus 7 plus 7 times 5. It's equals to negative 2 times 35 from here times 71. This is the summation. Plus 350, which is this one. And then we just add it. It will be the same result as this one. Cool.